Hello, good day. This is our assignment for this week on how neural network solve the XOR problem. First of all, we will take this target square as an example. The XOR or a series of problem is a classic problem in ANN or artificial neural network research. It is the problem of using neural network to predict the output of XOR gate given two binary inputs. An XOR function between a true value of the two inputs are not equal and a false value if they are equal. From this input data or possible predicted output can be tabulated in the table shown here. To solve this XOR problem, we can try using single language reception. This reception includes a single layer of input units including one bias unit and a single output unit. Here, the bias unit is depicted by a red circle while the other units are shown in blue circles. There are two non-biased input units representing the two binary input values of XOR. The perceptron is a type of feed-forward network which follows the process of generating an output known as forward propagation, flows in one direction from the input layer to the output layer. There are no connections between units in the output layer. Instead, all units in the input layer are connected directly to the output unit. A simple explanation of the forward propagation process is the input value of x1 and nx2 along with the value of 1 multiplied by their respective weights W0, W1, W2 and passed to the output unit. The output unit takes the sum of those values and employs an aggregation function, typically the value set function, which convert the resulting value to an 0 or 1, thus satisfying the input value as 0 or 1. In the city of which the variable that the network how to control over the process of converting input values to an output value. We interrogate that the single value the classification line, the line that separates data points into the classification group is drawn. If all data points on one side of the classification line are assigned equal to 0, the opposite are classified as 1. A limitation of this architecture is that it is only capable of separating data point with a single line. It is clear that a single perceptron will not serve our purpose as XOR input are not linearly separable. This is particularly visible if you plot the XOR input value to a graph shown here. There is no way to separate the 1 and 0 values into a single classification line. While this graph shows a potential non-linear division boundaries for XOR model. Non-linearity allows for more complex decision boundaries. One potential decision boundary for XOR data could like this.
My name is Aiman Syazwan. Okay, I will continue about the XOR problem. We know that the implementation of the XOR function would require a non-linear decision boundary. Okay, let's first break down the XOR function into its AND and OR counterpart. So, as we can see here, there are the input layer x2 and x1 with the hidden layer a2 and 1 and output layer. The solution to this problem is to expand beyond the single layer architecture by adding an additional unit without any direction access to the outside world, also known as a hidden layer. This kind of architecture shown in the figure is another feed-forward network known as a multi-layer perceptron (MLP). So the XOR function can be considered into two parts, which is a NAND and an OR. We can calculate this separately. We can just combine the result using the AND gate. Okay, we can see here we use a NAND truth table here, which is input 0, 0 will be equal to the 0, while input 0 and second input is 1 equal to the 1, 1 and 0 will equal to the output 1, 1, 1 will equal to 1. For the OR table also, when input 0 and input second 0 will equal to 1, 0 1 will equal to the output 1, 1 0 will equal to the output 1, and 1 1 will equal to the 0. Okay, for the next is a non-table, just like the OR part. We use the same code but train the model on the NaN data, so the output we can see in the figure. So when we finish the part in the NaN part and the OR part, this architecture, while more complex than that of the classic perceptron network, is capable of achieving nonlinear separation. Thus, with the right set of the weight value, it can provide the necessary separation to accurately clarify in the XOR input. Okay, if we plot the decision boundary from our model, which is basically from the OR and NaN model, we can get something like this, which has the line, two line in the between the middle right green dot. Okay. So for the next part, I will pass to my member.
Okay, hello. My name is Muhammad Ali Syawal bin Karib. I will proceed with our presentation. So for my part, I will explain about the gradient descent momentum and loss function of the learning algorithm. So for multi-layer perceptron, we use the loss function of mean squared loss function, because it is a very popular loss function where it makes some assumption on the data, something like Gaussian, and it's not always convex when it comes to classification problem. So it usually used here to make it easier to understand how perceptron works, but for classification tasks, there are better approach, something like binary cross entropy loss. So from the graph is displayed as the loss function of the sigmoid neuron, which is indicating for squared error loss. Error loss. So when we plot the loss error against the weight, we get the graph depicted in the slide. So our main goal is to figure out the weight vector corresponding to the point where the error is minimum. For instance, the minima of the error gradient. So that's all for the gradient descent momentum. And then for the next slide, it is about the back propagation. Back propagation, it's begin by comparing the actual value output by the forward propagation process to the expected value, and then move backward through the network, slightly adjusting each of the weight in a direction that will reduce the size of the error by a small degree. Besides, both forward and back propagation rerun thousands of times on each input combination until the network can accurately predict the expected output of the possible input using forward propagation. So to conclude that the back propagation itself is very essential method that will reduce the size of error and make the training data more accurate and preventing from overfitting graph. So that's all from our group for our video or this video slide. So thank you very much and see you again. Thank you.